Hello, my name is James Franck and I am a part of the Franck-Hertz experiment. My partner and I, Gustav Hertz, were able to study the project behind if mercury atoms have excited states. We were able to do this through an apparatus that took quite some time for us to make, and we were even able to coin the term Franck-Hertz drift tube that was a part of the apparatus that we used. Through this, we were able to use a filament that pushed electrons through our apparatus that had mercury vapor floating through. With this, there were inelastic and elastic collisions between the electrons and mercury atoms. There was a positive grid and a negative grid, and the electrons had to be at certain energy states in order to make it past or to each grid. And through this, there was graphical data that was analyzed in order to prove our theory behind mercury atoms having excited states. We were attempting to find and be able to record graphical data that proposed and proved the ideas that the mercury atom had excited states. Through this, we had a graph that had a y-axis of current and an x-axis of accelerating voltage. The significance of this was that the electrons coming through would collide elastically with the mercury atoms. The electrons typically would hold most of the kinetic energy after these collisions. Then you would have some of the electrons have enough kinetic energy so that would meet the excited state of a mercury atom, and when they would collide, it would be an inelastic collision. These different forms of collisions formed on the graph peaks and valleys that anyone would be able to observe the excited states of mercury and when it was occurring and which orbital it was pushing through and that type of thing. We were able to actually have graphs that had peaks and valleys, and through studying those, it proved our theory that mercury had excited states. My partner Gustav Hertz and I met at the Physical Institute of Wilhelm Friedrich University in Berlin. This is where we met and started our experiments in 1911. By 1914, we were able to present to the physics institution in Germany our findings on the Franck-Hertz experiment. In 1913, before we published to the German Physical Society our ideas and proposed them officially, Niels Bohr came out with the Bohr model, and this was the idea that atoms could only stay within their own energy states. Lots of physicists were trying to prove or even bounce ideas off of the Bohr model, and so we were one that was, Gustav Hertz and I were both attempting to help promote the idea of energy states in atoms with our Franck-Hertz experiment. Gustav Hertz and I met at the Physical Institute of Wilhelm Friedrich University in Berlin. This is where we met and started our experiments in 1911. By 1914, we were able to present to the physics institution in Germany our findings on the Franck-Hertz experiment. Specific role throughout the experiment, although Gustav Hertz and I worked together quite a bit throughout the experiment and bounced ideas off of each other, was to make an apparatus with the drift tube. My part of the experiment heavily relied on the drift tube that we were putting in the apparatus, and that helped our experiment very well. The rest of the experiment, I helped with several trials and mathematical differences in the experiments and trials that I was trying to prove the excited states occurred that way. Gustav and I did go hand in hand on most of the graphical data, though. Made a very large impact on the physics community because not only did it back the ideas of the Bohr model that previously the year before were presented, it also shifted physics from classical physics to more quantum theory with atoms. And with this and the promotion of quantum theory and changing such a large ideology with physics, we won the Nobel Prize in 1925. Franck Hertz curve made a significant impact on our experiment. Therefore, highlighting some of the more difficult ideas and breaking it down more, low voltages were able to increase the current, and this was increasing energy in the atom. Therefore, this is shown on the graph with the X and Y axis, and at around 4.9 volts, there was enough energy to reach the excited state of the mercury atom, and therefore that is when there are dips in the graph.